Hello all, I am Dr. Prabhas Sanjanbal. In today's class, we'll discuss about the construction of regular expression from finite automata using state elimination method. We have already discussed about how to construct a regular expression from finite automata using Arrhenius theorem. We have discussed in the previous classes so many examples we have already discussed. Okay, so from today's class onwards, we'll discuss about state elimination method for to construct regular expression from finite automata. Okay, now there are some rules are there are some rules. Just say there are some rules. Generally we have to follow four rules. We have to follow four rules to construct the regular expression from finite automata using state elimination method. So what is the first rule? Just say what is the first rule? The first rule is here: incoming edges to the initial state. What is the first rule? Incoming edges. This is important. Incoming edges to the initial state. So we have to check, is there any incoming edge to the initial state? Suppose, for example, this is one of the given finite automata. In the given finite automata, is there any incoming edge to the initial state? Is one incoming edge to the initial state. Just say, we can say here, transition B. Transition B, this transition B is the incoming edge to the initial state. So if any incoming edge to the initial state is there, so what to do? So in this case, what to do? Just introduce one initial state. Just introduce one initial state, means Qi, and keep all the remaining means finite automata as same. Just say how to write, what to do when this one means transition B is the incoming edge to the initial state. In this case, let's say we just introduce one initial state here. We just introduce one initial state, and this one as the similar. This is the similar, means same. This is the same. What this finite automata, A to A and B to B. All things are same. Just introduce one initial state Qi and join using epsilon. We can write like this. Just see. We can do. I'm just erasing this one. All things. That will be better understand for you. Just say here one incoming edge to the initial state, and just simply write what all finite automata means A to A and B to B. But initially A was what? Initial state, but here we'll just introduce new initial state just like Qi, and join using what? And join using epsilon. This is the simple thing, nothing more. Okay, so this is the first rule, what incoming edges to the initial state. What is the second rule? The second rule here, outgoing edges. Is there any outgoing edges from the final state? Is there any outgoing edge from the final state? Outgoing edges. Now we have to check. See, this is one of the finite automata. In the finite automata, is there any outgoing edges? Yes, one outgoing edges from the finite automata. So in this case, what to do? Just introduce one of the final state. I just erase here. That will be better understand for you. Let's see. Simply draw the given finite automata A, B, C. Initially B was what? Final state, but here B as initial state. B as non-final state. In this case, simply introduce one final state. Simply introduce one final state. Initially B was what? Final state, but here from B to QF, just join using epsilon. Okay, and another thing, the remaining automata are just keep same. Okay, there is no changes. This is the second rule. What is the third rule? The third rule is here. Is there any multiple final states are there? Is there any multiple final state? Just say this is the given finite automata. The finite automata contains multiple final states. Multiple final states means it contains more than one final states. Okay. What to do in this case? I just erase all the things. I just erase. See, A to B. So in this case, if it contains multiple final states, what to do? Just simply draw the same finite automata A to B A and A to C B. But initial B C both are final states, but here B C both are what? Both are non-final state. Just simply introduce one final state, and join using epsilon, and join using what? Epsilon. Okay, this is very simple. Then what is the fourth rule? Fourth rule is what? Eliminate all states. Eliminate all states one by one. Eliminate all states one by one except initial state and final state. Okay, eliminate all states one by one except initial state and final state. Okay, these are the four rules for state elimination method. So we have to follow in sequence order. We have to follow in sequence order. Sequence order in the sense, first we have to follow the first rule, then second rule, then third rule, then fourth rule. It does not mean that we first will follow the second rule, then we'll follow the first rule. No, it's not possible. It's not possible. First we have to follow the first rule, second rule, third rule, fourth rule. In this order we have to follow. Okay, this is very, very important. We have to follow all rules in a sequence order. All rules in a sequence order. Otherwise, you will make mistake. So now we'll see the example. Okay. So now we'll see the example. We'll try to understand all rules using the given example. Okay. So first, construct the regular expression. Construct the regular expression from the finite automata using state elimination method. Using the state elimination method. See. So first rule is what? Is there any incoming edge? Incoming edge to the initial state. First we have to check S. One incoming edge to the initial state. One incoming edge means from B to A. What? This is B. One incoming edge to the initial state. So in this case, what to do in this case? We have to introduce a new initial state. Okay, just write keep all means just keep the finite automata as same. Means see here, this is A, this is B, AB, and this is A, and this is B. All things are same. Just introduce one initial state, QI. New initial state and join using epsilon. Okay. So now we have to check. So now we have which finite automata we have to check. Now this finite automata. This is our new finite automata. Then we have to check now this finite automata. Okay. We'll not check the given finite automata. We have to check the new finite, means updated one. Updated one finite. We always check the updated one, updated finite automata. So this is our updated finite automata. Now the second rule. What is the second rule? Is there any what outgoing edges from the final state? Outgoing edges from the final state, just say yes, one outgoing edges from the final state, what? B to A. Since one outgoing edges from the final state. So what to do? Just introduce a new final state. So now we'll introduce a new final state. What? Just draw the first we have to draw all the means all states and transition just means remaining same. Every finite automata will be same here. So this is Qi, everything will be same. Qi, this is A, this is B, this is epsilon, this is A, this is B. Okay. So initially what B was final state, but here we'll introduce a new final state QF. We'll introduce a new final state what QF and join using epsilon Okay. Now which one is the updated finite automata? This one, the second finite automata. This one is the updated finite automata. That means we have to check this finite automata. Okay. So what is the third rule? Is there any multiple final states? No, there is no multiple final states. So okay, just skip the multiple final. Third rule. What is the fourth rule? Eliminate all states one by one, except initial and final state. Except initial. What is the initial state? Qi the initial state. What is the final state? Qf is the final state. So eliminate, that means we'll eliminate A and B as well. Okay, but one by one at a time we'll eliminate only one initial, any one state, except initial and final. So first we'll eliminate either A or B. As your wish, either we'll select A or we can eliminate B. Let here I'll eliminate A. First I'll show you. First I'll eliminate A, then I'll show you. Then in the second page I'll eliminate B and I'll show you what happens. Okay, don't worry. First I'll eliminate what? Let A, that will be eliminating element. Okay. When I'll eliminate A, just see. When I'll eliminate here A, what happens? When I'll eliminate A, all paths between, just say, all paths between Qi to B will be disturbed. Yes or no? Yes. All paths between Qi to V will be disturbed because here we just eliminate which state? State A. So we have to preserve all paths between these three states, means Qi, A and B. Okay, so we have to select, means all combinations, means preserve all paths. How? Just say Qi to Qi, then Qi to Qa, Qi to A, Qi to B, Qi to B. Then we select A to Qi, A to Qi. A means I'll just take all combinations between this green line. Okay, A to Qi, then A to A, A to B, then B to Qi, then B to Qi, B to A, B to A, and B to B. Okay. So here we are eliminating which state? State A. State A means, so no need to this combination because Qi to A to Qi no need, A to A no need, A to B no need, and B to A no need. These combinations, first we'll delete these combinations those combinations are containing what? State A. Why? Because since A is not there, so why, how to get the path? Since A is not there, how to get path from Qi to A? Since A is not there, so how to get path from B to A? It's not possible. Okay. So now we'll do here Qi, this is B. Because we have already eliminated state A, then this is QF. Okay. Now, say here B2 QF, the path is what? Epsilon. B2 QF, the path is epsilon. Just keep. Now we have to check Q to Qi. Initially, Q to Qi, is there any path? Q to Qi? No, there is no path. So just remove. Qi to B, Qi to B, is there any path from initially S? This one is the path, what? Qi to A and A to B. Let's see what? Qi to A, sorry, that is capital A and A to B. Qi to A, the path is what? Epsilon, and A to B, the path is A. That means Qi to B, the path is what? A. Qi to B, the path is what? A. So we have to preserve all paths. That is important. We have to preserve all paths. Okay. So then, so here there is no path from A, from B to Qi. B2, in the previous case, B to Qi, is there any path? No, there is no path. Just simply remove. B to B, is there any path? In the previous case, yes. B to B, one path is there. Let's see how to get B to A, B to A, then A to B, then A to B. B to A, what? B, and A to B, that is A. That means B. But remember, see here, B to B means here there is a self loop. Here there is a self loop. Okay. So initially, the path in the previous case and the current case, previous and current case, all paths are preserved. All paths are same, we can observe. In the previous case and the current case, all paths are preserved. Means all paths are same. Okay. So now we'll remove what? One by one. So already we have removed state A. Already we have removed state A. Now we'll remove what? State B. So then I'll write here Qi. This is QF. So when I'll remove, so I'll get only one path. What? A. This is BA. What? Self loop means BA whole star. So BA whole star, then dot epsilon. So what is the regular expression? The regular expression is here A BA whole star. The regular expression A BA whole star for the given finite automata. Okay. So in this way we can use the state elimination method to find out the regular expression. Okay. So one point. Initially we eliminate what? A. First we eliminate A state. So then now we'll eliminate first B. What happens? Just see. So first we have to, okay, first we have to draw this finite automata again. Qi this is A, this is P, this is QF. This is epsilon, this is A, this is B, this is epsilon. So here we eliminate A, but here we'll eliminate, I just erase, no need. Here we'll eliminate what? B. Let first I'll eliminate B. What to do? Means what happens? When I'll eliminate B, the pass between, just say, in this range will be disturbed. Okay, the pass between A to QF will be disturbed. Here we'll eliminate the state B here. So then we just select, just erase all the points. Okay, I'll just keep all paths preserved. What? A to B, A to QF. First A to A, A to B, A to QF, then B to A, B to A, B to B, B to QF, then QF to A, QF to B, then QF to QF. Okay, since, just say, since B already removed, so just remove all these paths. Okay, those are related with B state. Now we'll draw here QI, then A, then QF. Okay, so QI to A is epsilon, right? So now we'll check A to A. Is there any path? Just see, in the previous case, A to A, is there any path? S. This is A and B. A, B means self flow. A, B. Okay, done. A to QF. A to QF, is there any path? A to B, A, then epsilon S. This is A. Okay, done. So QF to A, in the previous case, QF to A, is there any path? No. QF to QF? No, in the previous case. Okay, this is our final finite automaton. Now we'll remove what? Now we'll remove A. So this is QI, this is QF. So we'll get what? Epsilon, then AB whole star, then A. So that means what is the regular expression in this case? AB whole star, then A. Remember, in this case, first we eliminate state A. So we'll get the regular expression is what? A, B, A whole star. In this case, we eliminate first initially B. We'll get the regular expression A, B whole star A. So remember, both regular expressions are different here. Both regular expressions are different, but both will generate all means same strings, but both will generate the same string. Okay, so that means finally we concluded that for one finite automata, for one given finite automata, many regular expressions exist. Many regular expressions exist. Okay, so this is very important point. For one finite automata, many regular expressions exist. Regular expressions exist. Okay, for any one finite automata, many regular expressions exist. Okay, so in this case, this is a b a whole star, when in this case a b whole star a, but both will generate the same string, but both will generate the same string always. This is important. That means, for example, it will generate a, it will also generate a, it will generate aba, it will also generate aba. Okay, okay, both regular expressions may be different, but both regular expression will always generate the same string. This is important. Okay, so if we'll eliminate one state, means a, what happens? If we'll eliminate first state b, what happens? We have already discussed. Okay, in the next class we'll discuss one more example of state elimination method. Okay, thanks for watching.